This is starting the screencast for Lesson 2. And Lesson 2 is about ocean currents. Okay? Your essential question that you should be able to answer by the end of this lesson. By the end of this lesson, you should be able to describe the movement of ocean water, explain what factors influence this movement, and explain why ocean circulation is important to the Earth system. Okay? So we're going to figure out, how does water move in the ocean? Okay. The TEKS, the Texas Essential Knowledge and Skill that we expect you to know at the end of this lesson, is that you are to recognize that the sun provides the energy that drives convection within the atmosphere and oceans, producing winds and ocean currents. This is the same objective that we looked at for Lesson 1. But Lesson 1 was specifically talking about winds, and this lesson is going to be about ocean currents. All right, so join me on page 438. All right, it says, what are ocean currents? Well, they are stream-like movements of water. Okay. Ocean currents that occur at or near the surface of the ocean are surface currents. Kind of makes sense. And surface currents are caused by wind. Okay? An example of a surface current is the Gulf Stream. This is a particular surface current that we're going to look at. If you scroll down here to the bottom illustration, notice on this map, this area in here is the Atlantic Ocean. This is Florida. This is, Georgia, South Carolina, up into Virginia, New Jersey, New York. Okay, so this is the east coast of the United States right here. Okay, and the Gulf Stream is a surface current that brings warm water up along the east coast, and this warm water current goes all the way across and works its way over towards Europe. Okay, and this is just one surface current example. There's many, many others. It's just this one we might pay more attention to than some of the others because it affects the weather here in the United States. Okay? All right. What affects surface currents? So here we are. Surface currents are affected by three factors: continental deflections, the Coriolis effect, and global winds. Okay? And these are the factors that keep surface currents flowing in distinct patterns all around the Earth. Okay, so let's hop down here and answer the question on the bottom of page 438, and then we will go to page 439. It's asking which area on the map is warmer, A or B. Remember, this is showing you the Gulf Stream, which is a surface current that comes up along the east coast. Notice that red indicates warm and dark blue indicates cool. So which area on the map is warmer, A or B? All right, so the Gulf Stream is moving warmer water up along the east coast this way. Okay, and so it's asking which area on the map is warmer, A or B. We know that A is warmer because A is color-coded red, and red indicates warmer temperatures. Okay. Okay, so now we're going to go on to page 439. All right. And we're answering the question, what affects surface currents? Well, here's one thing that affects surface currents: continental deflections. Okay? when surface currents meet continents, well, obviously they can't go through the continents, so they are deflected and change direction and run along the coast maybe of that continent, something like that. A good example is up here. Okay, it says currents change direction when they meet continents. You have this south equatorial current coming over towards Brazil, and then it's deflected and runs down the coast of Brazil, okay, and becomes this part of it is known as the Brazil current, okay. So, one of the factors that affects surface currents is continental deflections, okay. Another factor that affects surface currents is the Coriolis effect. Remember that the Coriolis effect is the apparent deflection of moving objects away from a straight line path because of the fact that the Earth is rotating. Okay? So just remember, we talked about that when we talked about winds. The deflection of moving objects from a straight path due to Earth's rotation. That's the Coriolis effect. And the Earth's rotation causes all wind and all ocean currents, except for the ones that are right at the equator, causes all of those to be deflected from a straight line path. So they curve, or they appear to curve. Okay? And it's the difference in speed of rotation that causes the Coriolis effect. I pointed that out when we talked about the winds, but it's the same sort of principle. Okay? At the equator is a much fatter part of a sphere than up towards the North or the South Pole. And so if you're standing on a point close to the equator, you have to move through a much larger circle in 24 hours than you'd do if you were living near the poles. Okay? So that difference in speed due to the rotation of the Earth and in different locations is what's going to cause that Coriolis effect for us. Okay? Wind and water traveling south from the North Pole actually go towards the southwest instead of heading straight south. That's because the wind or water coming from the north doesn't have as much speed, because remember, everything up here is not moving as fast because it's moving through a smaller circle. Okay? Wind and water deflect to the right in the northern hemisphere because the wind and water move east more slowly than the Earth rotates beneath them. Okay? So in the northern hemisphere, currents are deflected to the right, and in the southern hemisphere, currents are deflected to the left. Okay? The Coriolis effect is going to be most noticeable for objects that are traveling over a long distance. Okay? All right, let's go to page 440. All right. Again, we're answering the question, what affects surface currents? Remember, continental deflection was the first thing that affected surface currents. Coriolis effect was the next thing that affected surface currents. Number three, third thing that affects surface currents are your global winds. Okay? So, winds that blow across the surface of the Earth pushes the ocean's water along with it. Okay? Different winds cause currents to flow in different directions. So you're going to have currents moving in different directions depending on where you're located on the Earth. But anyway, for example, near the equator, the winds blow east to west primarily. And why is that? Because if you guys remember back from lesson 1, it's the trade winds that are the global winds that are between 30 degrees north latitude and 30 degrees south latitude. So it's the trade winds that are around the equator. And the trade winds blow generally from east to west. Okay? So winds blow east to west because that's from the trade winds. And so most of the surface currents in that area are also going to move in the same direction. Okay? What powers surface currents? It's right there. There's your answer. Okay? The sun, ultimately. Sun heats air near the equator more than it heats air at other latitudes. Pressure differences form because of these differences in heating. Okay? And remember that pressure differences in the atmosphere causes wind to form because air is going to move from high pressure to low pressure. So the sun causes wind to form. Winds cause surface currents to form. Therefore, the major source of energy that powers surface currents is ultimately the sun. Okay? All right, so down here, it says fill in the cause and effect chart to show how the sun's energy powers surface ocean currents. Well, the sun heats the atmosphere. We have uneven heating. Creates pressure differences. Causing wind. Okay. And wind causes your surface currents to form. Okay. All right, so let's go to page 441. Here is a picture of your global surface winds and where they are coming from and going to. You can notice like this area and this area, those are your westerlies. In here are your trade winds and up towards the poles. And down here are your easterlies, okay? Way down here, okay? Okay, so it's really should be no surprise that your global surface currents correspond to the way that your global winds are blowing, okay? All right, if you notice, for instance, let's look at the South Atlantic gyre, this big circulation here, and you'll notice that generally it moves like so. And you look at the same general spot up here as far as your global winds, and it's not perfect, but it generally shows you the same circulation. So the winds set up these circulation patterns. Okay, okay, and that's how you're going to answer number 9. Circle the same area on each map and describe what you observe about these two areas. And you can do that on your own. I've sort of done one example for you.